Okay, let's do this right triangle geometry again. Looks like some students were confused. Okay, so if you have right triangle here, ABC, this angle C is 90 degrees. Okay, and the sides measure A, B, and C. Okay, I told you about SOHCAHTOA. We define, these are definitions: sine, cosine, tangent. Okay, we define the sine of angle. So sine of angle A is opposite over hypotenuse. Opposite hypotenuse is the side that faces the 90 degrees, the longest side. So the definition of sine A is opposite over hypotenuse, which is A over C. What about if I say the cosine of B? Okay, cosine of B, what will be? Cosine is the adjacent of the angle. Adjacent. Okay, so it's right. What is it? Right here. So cosine of B is adjacent over hypotenuse, A over C. See that? So and then if we are asked to do tangent of any angle, for example, tangent of A, you use opposite over adjacent. So toi, keep that in mind. Okay, you don't have to memorize it. You just know because you're not going to be provided. Just practice and practice, and it will stick. Anyway, so sine A we know is the same as what cosine of B. Okay, so but watch, angle A and angle B added should be 90. Okay, since it's a triangle, this angle C is 90, so A plus B will be 90. You see that? What does that mean? That means angle A is 90 minus B, and angle B is also 90 minus A. You see that? So far, that's okay. That's simple, right? Okay, so we've shown that sine A is the same as cosine B, right? So sine A is cosine B. In place of B, we write what? 90 minus A. In place of B, we write 90 minus A because angle B is the same as 90 minus A. Okay, so that is how we arrived at these rules. Sine A is the same as cosine B, which is same as cosine of 90 minus A. And all these are true. All these, just keep these in mind. All these are true. Okay, okay, just know them, play with them. Okay, I've signed the exercises. Okay, now know some Pythagorean triples. Okay, so if we have this right angle triangle, we know that a squared plus b squared is equal to c squared. Okay, these always work. If we have right triangle like this, okay, 3, 4, 5, they always go together. 5, 12, 13, they always go together. And we can have multiples of these. So times 2, times 2, times 2. These are triples. So if you see any right triangle and you have two of the sides that are 4 and 5, then the third side will be 3. If you have 3 and 4, the third side will be 5. Same thing over here. If you have 12 and 13, the third side will be 5. Okay, let's see. Now, question 1 to 5, we're going to do this. In a right triangle ABC where angle C is 90 degrees, sine A is 5 over 13. We are asked to calculate all these. We are asked to calculate all these. Okay, so we are asked to calculate cosine of A. So what does this mean? Let's draw. Let's draw the right triangle. Let's draw it. Okay, we are told that this is this part C here, that's 90 degrees. So let's say this is A, B. We have A, B, C. Sine A is 5. Remember, sine is SOHCAHTOA. So sine is opposite, right? Opposite 5 over hypotenuse 13. That's what it means. So you use this to label your triangle. Opposite, so hypotenuse. So we know it's 5, 13. We've been asked to calculate cosine of A. What is cosine of A? So cosine is adjacent over hypotenuse. It's right here. Well, we don't know that. Okay, you can use Pythagoras theorem to calculate it, but if you remember your triples, 5, 13, and 12, okay, form a triple. So what do we know about cosine of A? So cosine of A is adjacent over hypotenuse, 12 over 13. You're done. I can calculate tangent of A. Tangent is 3. Opposite over adjacent. Opposite over adjacent right here. So it will be, opposite 5 over adjacent right there. So it will be 5 over 12. Okay, see that we are done. 12 over 13, 5 over 12. What is sine B? Sine B, go to angle B and follow opposite over hypotenuse. Okay, opposite right here, 12 over hypotenuse 13. What about cosine of B? Cosine of B, okay, B is right here. Cosine of B, okay, adjacent is right there over hypotenuse, 13. Tangent of B, opposite over adjacent, 3. It is 12 over 5. And you're done. So you can get this done in a minute. So that's how you use the SOHCAHTOA. Okay, here's another question. If sine x equals 0.6 degrees, what is cosine of y if x and y are complementary? Okay, complementary, x plus y, that means it's equals to 90 degrees, complementary. So now we've told, okay, x and y are complementary, 90 degrees, and sine x. Remember we did that sine x is cosine of y. Remember we did that sine A equals cosine of B, and is equal to what? Cosine of B, the same as 90 minus A. So what is the question here? How long will it take you? 1 second. They say sine is 0.6 negative. So it's the same value. Okay. Now, what about this here? If sine of A degrees is cosine of B degrees, okay, and you're given A equals this value and B equals that value, what is the value of P? Okay, now if I know sine of A, okay, if sine of A equals sine of B or cos of B, what did we say? A and B are complementary. Okay, so now, okay, that means A plus B equals 90. So A equals 90 minus B, or B equals 90 minus A. Now we have system of equations. Okay, from complementary, 2 is given, 3 is given. So by substitution, you see A equals 90 minus B. This is A. Come and put it over here. This is B. Come and put it over there. So by substitution, AP minus 44, that's the A, is equal to 90 minus B. Okay, so we get rid of all variable except the one we are looking for. Now we have one linear equation in P. We solve for it. P equals 8. You follow it? Follow it? Okay, this is important. What does it mean? Sine A equals cos B. What does it mean? A and B are complementary. Okay, we use that form system of equations, plug it in, solve it, pause the video, absorb it, redo it. Okay, notes. Okay, these are some definitions in pre-calculus or trigonometry. If you see, now you know cosine, you know sine, you know tangent. Okay, the reciprocals of these, we take reciprocals, then we form different angles here. We say cosine, reciprocal is secant. So when you see secant of x, don't panic, it's just this 1 over. Cosecant of x is 1 over sine x. Cotangent of x, 1 over tan x. Keep that in mind. All right, these are your IXL exercises. Algebra 2. Algebra 2. Do all these plus z5. And remember, if sine x equals cosine of h minus x, then what is h? Okay, this h is 90 degrees. Remember, keep that in mind. That means this here must be 90 degrees for this to hold. Or 90 degrees the same as pi by 2, since pi is 180. Got it? Okay, so this question here, what does this mean? If cosine of x equals the sine of 2AW minus, you see that with minus this, and these are the same. So whatever is here is 90 degrees. Okay, that's what it means. So this whole thing is 90 degrees or pi by 2. If the cosine of an angle is the same as sine of something minus the same angle, then this must be 90 degrees or pi by 2. Since we are told in the question that the angles are in radians, that means 2AW, this whole thing is pi by 2. And we are told A equals 1 over 4. We come and plug it in, simplify. 2 divides here, 1, 2 divides here, 2. We get W over 2 equals pi by 2, which means W equals pi. Okay, so I hope this helps. Any further questions, let me know. So we have a right angle triangle, and you can make all these conclusions. Sine A opposite over adjacent is the same as cosine of B. Okay, so that we've proven that. And then since they are complementary, sine A, okay, A plus B equals 90. That means B is 90 minus A. And then all these are true. Okay. All right. Send me any questions. Send me email about any questions. Keep on practicing, and everything shall turn well, all things being equal. Bye bye.